Today we're going to speak about probability of independent and dependent events. When can we say that those events are independent? Two events are independent if the occurrence of one has no effect on the occurrence of the other, which means that if one happens, that doesn't have to do anything with the other event happening. If A and B are independent events, then the probability that both A and B occur is probability A and B equal probability A multiplied by probability B. For example, rolling a number cube and getting a 4, and rolling a number cube again and getting a 3. Those are totally independent events. If I get a 4 for the first time, doesn't have anything to do with getting a 3 the next time. So that's why I have probability A and B equal 1 over 6 multiplied by 1 over 6, which is 1 over 36. This is an independent event. Now, when two events are dependent, if the occurrence of one affects the occurrence of the other, the probability that B will occur, given that A has occurred, is called conditional probability. Probability B if A happens. Probability A and B equal probability A multiplied by probability B if A happens. Let us see an example for that. What is the probability of selecting a king, then another king from a standard 52 card deck? Probability A is the normal standard, which is 4. I have 4 kings in my cards over 52. What about probability B, provided that A happened? For the second time, I'm going to draw a king. How many kings do I have remaining? I only now have 3. How many cards do I have? 51 and not 52. So see, probability A, or the action A, has occurred and the event has affected the event B, which means that this time getting a king is not going to be 4 over 52, it is going to be 3 over 51. So accordingly, I'm going to have probability A and B equal 4 over 52, which is probability A, multiplied by probability B, provided that A happen, which is B slash A, which is 3 over 52. I get my answer 1 over 221. That is when my two actions are dependent. Now, the probability of selecting a rotten apple from a basket of apples is 12%. What is the probability of selecting 3 good apples from 3 different baskets? First, I'm going to get the probability of having the rotten apples, which is 12 over 100. Remember, P complement, or P complement A, which means that the rest of the apples which are not rotten, which is 88 over 100. Probability of having 3 good apples, which means I'm going to use the 88. How many times? 3 times. Why? Because they are independent events, because he said that I'm going to choose them from 3 different baskets. So choosing 1, choosing 2, and choosing 3 are not going to affect each other. They are going to be 3 different, but I'm going to use the complement, which is 88 over 100, 88 over 100, 88 over 100. Now, selecting 1 good and 2 bad. 1 good, which is 88 over 100, 2 bad, which is 12 over 100. How many of those do I have? I have 2 12s and 1 88. When I multiply them, I get this. Selecting 2 good and 1 bad, same thing. 2 good, which is 88 times 88, multiplied by 1 bad, which is 12 over 100. Now, selecting 3 bad apples, which is 12 over 100 multiplied by 12 over 100 multiplied by 12 over 100, I get my answer to be 0.00173. So this is how we use the probability of the complement probability in order to get my probability A dash and A dash and A dash, which is multiplied, and they are independent events. That's why I'm going to use the same one again. What if I told you I'm going to use the same basket? Should I have the 88 over 100, or should I have a different one? probably I'm going to have, if it is dependent, I'm going to have 87 over 99. And then 87 over 99, and so on.